Doing great, thanks. All right, so I haven't pulled down PA-A repos yet completely, but I'm assuming that worked for everybody. But any questions or issues or problems as far as Git or as far as, compiling and running your first Hello World for the course? Pretty much good to go. All right, so yesterday we dug into a little bit of the string class, and we looked at that, and we wrote some code using the string class. So yeah, you're welcome. So I want to look at creating classes now, right? And your first programming assignment is going to be building your own class to implement a new data type that handles fractions, basically. So I want to start digging into some of the specifics of how we make a class and start getting a better idea of objects from that perspective. So let's write some code. So let's create a rectangle class. All right, so this is kind of a classic example for object-oriented stuff, but we're gonna make rectangles. And a rectangle is going to have a length, and it's going to have a height. Now, we're not going to do GUIs, though, not yet. We're going to have to imagine that we can see these rectangles. But we will get to GUIs eventually. And we'll have fun with that. All right, so my main class is going to be, we could do triangles instead. Yeah, let's do a triangle, man. Well, then I gotta remember formulas for triangles. Alright, let's do triangles, because I've done rectangles every time I do this course. So let's do a class triangle. And a triangle has a length, and it has a height. I gotta make somebody get me the formula for perimeter, though. So area is 1/2 base times height, good. And we got Pythagorean formulae on there, good. Alright, so let's make a triangle test class, okay? So remember, anytime that you make a class named blah, it's gotta go in a file named blah.java, okay? So I'm making a triangle test, so I'm going to call this class triangle test. And I'm going to put a main method in here. No, we're not going to assume equilateral. I don't think we need to. So we'll have our main method. Alright, so that's our triangle test class. Meanwhile, let's make a class for the triangles themselves. Okay, so convention. This is not required by the compiler or the JVM, but if you don't follow this in 2021, you will raise eyebrows, okay? Convention. Classes start with uppercase letters. Objects start with lowercase. Okay? No particular reason, but you know, class, that's uppercase, object, that's lowercase. So if I'm defining a class called triangle, I'm going to call it try with an uppercase T. If I actually create a triangle, right, that's going to be the name of an object that's going to start with a lowercase letter. Again, there's nothing about Java that makes that mandatory, but that is almost absolutely standard. And if you start making classes with lowercase names or object with uppercase names, your friends won't sit next to you at the lunch table, or they'll guard their food if they do. So, so I'm going to call my class try with an uppercase T. And I'm going to even throw some comments in here. This is a basic class for defining and working with triangles. That's not a very useful comment, but you know, that's okay. Yeah, shunned by computer scientists everywhere. So what do we need to constitute a triangle? Well, we know that we need to know the height and the length of the triangle. So let's make those part of our class, part of our structure. And I'll go ahead and make them doubles. Why not? Yeah. Alright, so that may be all that we need for our triangle class, right, for now. So it's just a length and a height. So back here in my triangle test, I want to have some triangles, okay? How do I create an object of type triangle? I'm just going to say try T1. Okay, now if I wanted an integer, I could say integer I. If I wanted a string, I can say string S. I want a triangle, I'm going to say try T1. Alright, that gives me a triangle. Alright, and let's assign some values to the length and the height. And then let's see what happens when we compile this. Alright, so I've got two files right now. I've got my triangle class itself, which is called try, and I've got my triangle test class, which I'm using just to hold my main program. So let's compile trytest.java. Okay, and I get an error. So the error says variable t1 might not have been initialized. And this is not just a warning, this is an error. This will stop it from compiling all the way to a class file. Alright, so let's take a look at this. And let's think about C for a moment. So in C you can say something like integer I, and you can immediately start using I. But if we don't give I a value, printing the value of I or putting I in an if statement or a while loop doesn't make sense, right? You really need to give it some value. But we can compile that and see, we can run it, we just get weird things. But when we have, you know, more complex things like, you know, a struct node star root, and then we start saying something like root arrow data equals 5, right? This is worse, right? This will probably segfault on us, because we've told the compiler root is a pointer to a struct node, but we haven't given root a value, right? Which means root is probably null, and when we try to dereference null, we get a segfault. So just like we need to give I a value here, we need to usually do something like root equals malloc, such and such. Alright, so this is the case in C, right? We're defining, you know, some kind of structure here, or a variable, or a pointer to a structure, before we can use it, we have to actually give it a value, right? And the same thing is happening in Java here. I've said T1 is going to be a triangle, but it's not actually any particular triangle yet. We need to do something like malloc. So here's the setup. Okay, C1 is a reference to a trie. But it doesn't have a value yet in some sense. So yeah, so someone in chat just pinged it, right? We need to actually create a trie. We need to construct a trie and have T1 point to that. And the way we do that is T1 equals new trie. Okay, and this constructs a trie, or sometimes we say it instantiates a trie. It creates an instance of a trie. So remember, your class is a blueprint. It's a picture, it's a recipe for the thing that you're going to eventually build. The object is the actual thing that's been built from that blueprint. Okay, the constructor is the thing that makes the object from the class. So we've got a class, trie. This is like a blueprint. Or a schematic diagram, since we're engineers. This is a schematic diagram of the circuit. Okay? When you say trie, so that's the blueprint. We can say trie T1. T1 is going to be a trie. Okay, it's a thing that's going to be built from this blueprint, but it hasn't been built yet. So we construct it, we instantiate it, we build it by saying T1 equals new trie. And yes, new is a keyword in Java. So this says construct T1 from the blueprint called trie. So yeah, new is a specific keyword, and this is constructing a triangle, right? A trie from that blueprint, that class description. And once we've done that, now T1 exists. It is a triangle, and so we can talk about its length, and we can talk about its height, and we can do things with it. And so if I try to compile this, that'll compile just fine. And if I try to run it, it says hello. I didn't do anything with the length and the height. Let's see, do we have to write trie T1 before the constructor? Yeah, so you've got to tell it that T1 is going to be a trie before you can construct. But you can do this in one line. I could say trie T1 equals new trie. Yep, absolutely. Just like in C, we can malloc on the same line that we can declare. All right, now that I've compiled this, I have 4 files in my directory. I have a class file corresponding to trie test, my main class, and I have a class file corresponding to my triangle class. All right, so this compiles. So our constructor always uses the keyword new, and then it's the name of the class, and it's got to be followed by parentheses. And the reason it's followed by parentheses we'll see in a little bit, but basically because sometimes we want to pass arguments to our constructor. All right, so that constructs T1, and so we could go ahead and we could say trie2 equals new trie. And there's a second triangle. And we'll make that a little 5x5 triangle. All right, so that's construction. I'm making notes here so I know what I've talked about. All right, so far this is working just like a structure in C, right? Try is basically try is basically just, you know, a structure statement. It's got two fields called length and height, and we can access those fields with periods, and we can give them values and so on and so forth. So that's fine and that's good fun, but we can do a lot more. So let's make a constructor inside our triangle class. Okay, so let's define a constructor. So when you want to make a constructor, you do it by making a method. It's going to be public. It's going to have the same name as the class, and then if you want to pass arguments to it, you can put those inside the parentheses. And I'm just going to print a message in here and say I'm inside the try constructor. Yeah, we don't have a whole lot of includes yet at this point. We'll have to do imports, which are like includes, when we start using other classes like hash maps and things like that. But for things that we're building ourselves and built-in things like strings, we don't need to include or import. All right, so this is an example of a constructor. Now, if I don't have this, there's a default constructor, which doesn't really do a whole lot. It just basically mallocs some memory and, you know, knows that there's references to these things inside. Yeah, we need the Minecraft object. But the constructor doesn't have to be written. But I'm going to write a constructor here, and when I do my new try, it's going to actually execute this method, this code. And it's going to do the stuff that a constructor normally does. It's going to malloc some memory and so on and so forth. But, you know, it's also going to presumably print a little message here. So let's compile this. And let's run it. And what did it do? Well, it printed out my constructor message twice, right? Why? Because I called the constructor twice. Yeah, exactly. Yeah, there is. All right. So why do we want to build constructors? Well, because sometimes we want to do things inside constructors. So let's expand on this code a little bit more. Let's print out what T1 looks like. I'll print out a message. T1's dims are, and I'll print out the length by the height. And let's do this for T2 also. All right. So we're inside here. T1's dims are 10 by 20. T2's dims are 5 by 5. Which we would expect because we initialize the length and height of these accordingly. All right. So why do we want a constructor? Well, we can do the following. Suppose we set up our constructor to initialize our triangle. right? So let's do this first. Suppose I don't do this. Right? So I didn't initialize my length and height for T2. It turned out to be a 0 by 0 triangle, which isn't terribly useful. So instead, let's change our constructor. And in my constructor, I'm going to set a default length and height to be 1. And I'm going to do that just by saying length equals 1, height equals 1. So it printed the hello once because I only printed hello in the very beginning of my main program. But then I called a constructor here that printed out I'm inside the constructor, and I called a constructor here and that printed out the second time I'm inside the constructor. Alright, so inside the constructor now I'm setting the length and the height to 1. And this is strange stuff, right? So because all I'm saying is length equals 1, height equals 1. I'm not saying which object's length and height I want equal to 1. But when I say length equals 1, I'm talking about this variable right here. And when I say height equals 1, I'm talking about that variable right there. So here's the thing. In my main program, I'm going to say T1 equals new try. I'm constructing a new triangle, right? That new triangle has a height and a width, and the height and the width of that new triangle are 1. And so when I say something like T1 equals new triangle, after this comes back from this call, T1's length and T1's height will be equal to 1. And I'm changing them to 10 and 20 here, but T2, for example, I'm setting a new triangle whose length and height are equal to 1. I'm setting T2 equal to that. And if I don't change those, then when I print out T2, it should be a 1 by 1. Let's see, couldn't you make it so inside the class you can the new? I'm not sure what that means. If you can ask that again. And yeah, we're talking about this, but I'm not going to talk about the keyword this for a while. But you're right. Yeah, this is what we would do with this keyword. All right, so I'm setting length and height equal to 1. Let's go ahead and run this. Right, so I do this, and T2 is a 1 by 1 triangle now. Let's see, couldn't you make it so that inside the class you can do new instead of the main program? I don't think so. I mean, when you're inside the constructor, the only way you get inside the constructor is by using the new keyword. So you wouldn't have a way to actually get into it. Could you classception where you call new? You can create new classes inside a class, yeah. And if we try to create a new triangle inside the constructor, I don't know if it will catch that or not. I've never tried that. Yeah. You can do that, and then you run out of stack space. But it makes it pretty far. There we go. Stack Overflow. Woo. All right, let's see. It was just Java. Just use all classes in the current directories if they were included. Yeah. So if I try to use a class like TRI, it's going to look for it in my current directory, and if it doesn't find a try.class file in there, there's a list of directories in which it will search for classes, and there's some defaults that it will use for things like string and so on and so forth. So there's a whole hierarchy, something like a path, yeah, a class path. All right, so we'll take out the evil statement. All right, so we've got a length and a height. What happens if we try to print a triangle? All right, because we can concatenate things with a plus sign, and plus signs seem to work with like integers as well as strings. So let's go ahead and print out our triangles. And it doesn't blow up, but it doesn't give us something terribly satisfying, right? It says T1 equals try at sign some hex number. T2 equals try at sign some hex number. All right, so yeah, those are basically pointers, but we don't use the pointer word in Java usually. But they're basically references to triangles. They're internal pointers. But we'll figure out how to fix this later on. Yeah, hex memory address, exactly. All right, so let's look at let's make triangles interact with other triangles. Nope, we don't have to mess with pointers. That's an internal notion, right? And because we didn't tell it how to print a triangle, all it can do is give us its reference to it. But we're not really going to work with pointers at all in Java. Okay, so I'm going to define something goofy. I'm going to define a way to add two triangles together. Okay, so T1 looks like this, and T2 looks like this. And so I'm going to define T1 plus T2, and all I'm going to do is I'm going to add the heights, and I'm going to add the lengths. All right, so this is just life without pointers is pointless. There you go. All right. I'm going to define addition. So T1 is going to be, length 1 by height 1. And T2 is going to be length 2 by height 2. Then T1 plus T2 is going to be length 1 plus length 2 by height 1 plus height 2. So we're going to do a really, really simple arithmetic operation. We're going to say we can add two triangles, and the result is a new triangle whose height is the sum of their heights and whose length is the sum of their lengths. Okay, so I'm going to create a method called add, and it's going to be public, and it's going to return a triangle. I'm going to put some stuff in here. and my result's going to be a new triangle. And I'm going to set its length to something. And I'm going to set its height to something. And I'm going to return that as the value of the function. We might need some statics in here. We'll see. I'll try to avoid those. All right. So how are we going to add triangles together? We're going to define a triangle T1, T2, and T3. And we're going to construct T1 and T2. And I want to do something like T3 equals T1 plus T2. All right. Now we can't use the plus sign. If you can redefine the plus sign, that's something called operator overloading. Some languages let you do that. Java does not. So we're going to use a function. And if we were doing this in C, we might do something like this. We might make a function called add, and we would pass the two triangles to it and take the return and store that in T3. Okay, but that's not really object-oriented E, right? The way we want to think about this is T1 is a triangle, and we want to add T2 to T1. And so we're actually going to do something like this. We're going to take T1, and T1 is going to have an add method, which will take a triangle and add it to T1. And then we could say something like T3 equals T1.add. Okay, this is the essence of CSE223, right? This is the leap from C to Java, from non-object oriented to object oriented. We're going to write a method inside the triangle class called add. And add will take one argument, which is the triangle you want to add to, in this case, T1. If I wanted to add a triangle to, T17, I'd say T17.add, and I would pass it the triangle I want to add to it. And if you wanted to add three triangles, you could do T1.add, parentheses, T2.add, parentheses, T3. Exactly. So let's wire this up and see what it looks like, and then we can think about it some more. So I just closed my chat window, man. All right. So my my triangle method is going to take a single triangle called, add me. And triangle length is going to be addme.length plus what? So, and I put this in the wrong place. Hold on. Okay. Yeah, this belongs in the triangle class. Sorry, that was some of the confusion going on in chat. All right, so in the triangle class, I'm making this method called public try add. And it takes an argument, which is also a triangle. The argument is called add me. I'm creating a temporary result that's just a new triangle. And then I'm saying that result's length should be the length of this triangle you're adding. And then what length do I want to add to that? I really want to add this length right here. So it's really just plus length. And the thing to keep in mind is that when we're inside the add method, right, we got there because we said something like t1.add, right? You're running this method as part of this object t1. So inside this add method, length refers to t1 length. Height refers to t1.height. Right? So result length equals the argument's length, add.me's length, plus my own length. Cool. All right. And then we'll set the length and height of result accordingly, and we'll return result. All right, I'll post this code on the server later. All right, so let's add some triangles together. All right, so I'm going to take t1.add t2. I'm going to store the result in a new triangle called sum. I could do this in 2 lines. I could do this in 1 line. All right, and I'll print out what sum looks like afterwards. I'm going to get rid of this silly print statement for now. All right, so T1 is 10 by 20, T2 is 1 by 1. The sum's dimensions are 11 by 21. So this is how we call the add method of T1, and we're saying T1.add T2. And when the JVM executes that line of code, it's going to look at T1 and say that's a triangle, so it's going to look for an add method inside the triangle class. It's going to set add.me equal to T2, and it's going to make a new result. It's going to take T2's length and add the length of what? The length of T1. Why T1? Because we said T1.add. Now if I had said T2.add T2, right, I get a 2 by 2 because I added T2 to itself. And this is just like doing, you know, s1.length when we wanted the length of a string, or s1.character at parentheses I when we wanted the ith character of a string, right? This is accessing a method that's part of this object's class, and we're passing an argument, which in this case is T2. All right, so there's a lot going on in here, but this is, you know, the transition from non-objects to objects, basically. All right, so yeah, this is kind of exciting, right? And wacky. All right, let's do some more stuff. Let's make a reset function. Yeah, so when I started doing Java, I sort of learned the mechanics of how to write code that works, and I didn't understand what was going on either. But yeah, basically love child between functions and structs. Good Good paraphrase. All right, we're going to make a function, a method inside the triangle class called reset. And reset is just going to reset the dimensions to some standard value. So what should we have reset do? We'll just reset it to a 10 by 10. So public, and this method doesn't have to return anything. And it doesn't need any arguments. Right? When I call this, I'm just going to say object name dot reset. I don't pass anything to it. I don't do anything with a return value. Right? And in C, we would say something like, you know, T2 equals reset, or T2 equals reset parentheses T2. But really, we're just trying to execute a method, a bunch of code inside this class. And so we're going to make a method called reset. It doesn't return anything, so we can say void. It doesn't take any arguments, so we say paren. And we're just going to say length equals height equals 10. And that'll reset it. So after we reset it and we print out T2, T2's back to being a 10 by 10 now. All right, so let's kind of ignore the word static for now. For now, the only time we're going to use the word static is in our main program. Right here when we say public static void main, we're going to use the word static there, but we're mostly not going to use that for a few weeks. So when I'm writing things in my class, when I'm putting variables in here, when I'm making methods, I'm just going to make them, you know, public, meaning that we want to be able to access them outside this file. Void or try or int or whatever type they're supposed to return. The name of the method, and then the list of arguments in parentheses. And the one exception to that is when we're defining a constructor, we don't say what kind of thing it returns. And the constructor has to be the name of the object, the class that you're constructing from. So if I'm making a constructor for try, it's got to be called try. It's going to return a try, but it would look weird to say public try, right? So we just use the name and it's understood that's what it returns. We would avoid the use of public. We could use private if we wanted to write some code in here that we didn't want the outside world to interact with, right? And this gets into this whole idea of information hiding. So remember in 222 in particular, we started talking about this notion of abstract data types. And when we implemented a stack, right, we had this variable called a stack pointer. And we had an array of values, and we had some functions called push and pop. And we wanted the user, the main program, to call push and pop, but we don't really want the main program to modify the stack pointer, or look at the stack pointer, or modify the things in our array. So the stack pointer and the array, we would declare those as private. And then anything outside of that file that we're writing those pieces of code in has no access to those variables or those methods. They're hidden, right? So we'll play more with that as we start building out packages. But for now, we can make everything public and non-static except for the main program. All right, we got 5 minutes left. Let's talk about toString. So, you know, we tried printing out these strings, these triangles, and we got weird stuff. When we try to print these, we just got these weird, you know, blah blah blahs, right? All right, so there's a trick we can use. When we do this plus sign, when we say, you know, concatenate this triangle to this string, it comes up with its own way to do that, which is to take the name of this object's class, which is TRI, and then put on an @ sign, and then put on this internal memory reference, right? And that's not terribly useful. We can define how we would like these triangles to be concatenated to strings. So we're going to do that by making a public method which returns a string, and it's called toString, and it takes no arguments. And I'm just going to make my toString return the string haha. All right. And when I run my program now and I try to concatenate T1 to the string T1 equals down here, it's going to concatenate haha. So I'm overriding the default way that Java will concatenate a triangle to a string. So there's a built-in toString which says, hey, if somebody wants to basically turn a triangle into a string, let's return the string TRI followed by an @ sign followed by basically the address of that triangle. But we can override that. And this is one of the key concepts of object-oriented design, is being able to override built-in methods. All right. So I'm going to, you know, just return haha. If I decide that I should return LOL, right? When I concatenate a triangle to a string, it turns it into LOL. But I can do something a little more useful. I'm going to make a string that looks like the letter A, followed by the length, followed by an X, followed by the width, followed by the word triangle. I'll put a period at the end. Ooh. Height. Height, nope, it's length. Height. It's a return statement. There we go, thanks. Alright, so now what's happening? Over here, I'm just printing out T1 equals plus T1, T2 equals plus T2, but what is actually coming out is T1 equals a 10 by 20 triangle, T2 equals a 10 by 10 triangle. All right, so now we've got a nice way to look at triangles by just, you know, putting them in a print statement. And a really important point here, and then we're done. I'm not printing anything from my toString method. All I'm doing is returning a string, right? But in my main method, I said let's print out, you know, T1 and T2, and those got turned into these strings, and then this print statement in my main program printed out T1 equals a 10 by 20 triangle, and so on. All right, so I'll post that code onto Canvas, kick it around, modify it, write your own versions of it. Try to get a bit of a handle on, you know, defining a class, constructing it, working with the fields in there, and then the really cool biggie part was this, right? Accessing a method from inside here and thinking about the code that corresponds to that method. All right, and the more you get on top of that, the more you're an object-oriented programmer. All right, cool. Have a good one. I will see you tomorrow.